Hi everyone, and good afternoon. Thanks for joining us on this webinar today. My name is Henrique. I'm life cycle designer at E2, as well as responsible for business development. So we'll run through how E2 have been using life cycle design methodology to provide value to clients and the services that we offer. So the idea is to run through these topics and leave some time for us to interact at the end. We'll cover the life cycle design methodology. I'll quickly introduce the E2 LCD software, and then I'll show the 5 ways you can add value to your services using the methodology. We can look at specific projects. If you have questions on projects that we're working on at the moment, then you have some time for us to interact at the end. So a bit of background about E2 for those who haven't heard of us before. We've been around since 2010 and completed over 200 LCA studies in Australia and internationally. So we are kind of leading this space in terms of providing consulting services and also software services for lifecycle design. Our ultimate goal is to design zero carbon buildings, so we always work towards that goal and providing recommendations, looking at the environmental and financial performance of the projects that we are designing. So it's simply building better using E2. We do work in the Green Star space, so here's a few projects that we've worked on. The University of Melbourne, the School of Design, it's a pretty cool building, as well as some office buildings here in Perth that we did with Broad, Cundall and John Holland. The client was Leighton Properties. Then we go into different types of student accommodation, timber frame building, quite interesting and pretty good carbon savings, global warming potential, so 60% savings when compared against equivalent building. All these projects, they are in E2 website, so feel free to jump online and get more information if you like. And then we move into larger scale projects, from stadiums to bigger infrastructure components, and then we also do multi-residential projects, assisting developers to get good performance buildings and lower operational costs. So multiple different types of multi-residential projects, different developers, and detached houses. So we work from small detached houses all the way through big, large infrastructure projects, assisting moms and dads, doing good for the planet, but also working with architects and designers and engineers to do more sophisticated analysis on bigger projects. So the reason why we are excited about the build form is that it's represent a big portion of the impact. You know, this is a map, shows the emissions, so greenhouse gas emissions per person per year. And here in Australia, we are at around 20 tons, 25 tons per person per year, whereas worldwide, we are currently at 7 tons per person per year. There's a drastic change required here if you want to achieve a sustainable level. With 9 billion people on this planet, we need to drop it right down to 1 ton. So that's the biocapacity of the planet to cope with the emissions and still find a balance. So the built form represents 35% of the overall greenhouse gas emissions, and with E2 we're hoping to address that with the new projects that we're working on. How do we actually quantify? It's a very interesting question. You know, how do we know if the buildings that we are designing is helping us get to the happy planet, and where do we see it? You know, how well the buildings that we are designing perform. So we really need to quantify things and use the scientific approach to understand it. And that's where the methodology comes in. When you look at the history with the green building ratings, they started when they kicked off. It was before we had the standards for measuring sustainability performance of buildings. So you see now green building ratings using life cycle assessment as part of the framework, and we see that as a trend in the industry where you have more standardization. So you have the international standards you developed that can help develop education for the industry, as well as software providers, and use a performance-based approach instead of using a very prescriptive approach. So that's what we see. It's happening, the mix between life cycle design and green building ratings. So essentially, life cycle design is a methodology. It's not a rating system. It's more of a design methodology that uses life cycle assessment to initially quantify the performance. Then we compare it against a reference case, could be a benchmark or codes compliant building. Then after we understand the problem, we then improve the performance. So there's a process of quantifying, understanding the impacts, and then allowing us to improve the overall performance. So E2 is specialized, it's focused on environmental performance. When we're talking about sustainability, we don't look at social impacts, although you have standards and you can quantify a bit of social performance. We mainly focused on environmental performance and financial. So it's important to mention that. So very quickly, the life cycle design methodology is a combination of both the life cycle impacts, understanding where stuff comes from, what happens at the end of its life, from materials extraction, transporting those materials to site, assembling, putting the building together and operating it for 50, hopefully 100 years, then accounting for all the recurring impacts throughout its life, as well as all the end-of-life impacts when the building gets demolished or redeveloped. So that's the life cycle impact aspect of the methodology, which is one aspect, but we also have the functionality. The functionality will look at the durability of that project, design life. What is the primary function of that building? If it's a residential building, how many occupants you get into that building? There's no point of designing a sustainable mansion, for example, when you only have 2 people living on it. So we need to look at the overall impacts as well as the functionality. So design life, as I've mentioned previously, will dictate, the impact per year, and the longer we can maintain the building for, the better. So you dilute all the impacts, the initial impacts associated with construction and the materials over a longer period of time. And then we look at occupancy, if it's a residential project, or we may be interested in looking at the net lettable area if it's a commercial project. So we want to maximize the primary function of the buildings that we are designing and make sure we get good functionality. Then after tackling functionality, we look at the efficiency part of the design, which is the most common aspect that we are used to, which is looking at things like energy efficiency, water efficiency, durability of materials, automation, using renewables on site for either electricity or thermal. And then we look at the materials durability, maintenance, or the end-of-life impacts. So all these aspects are looked at once, integrated in one single model. So different functional units for different building types As an example here, we have a residential that is assessed by impact, so tons of carbon per occupant per year. If it's a commercial building, we'll look at the kilograms of carbon or tons of carbon equivalent carbon emissions on a per meter or per meter square of net lettable area. If you're looking at a hotel, for example, you can assess the performance on a per bed, occupied bed basis, or a per seat basis if you're looking at stadium. So the more people you can get into a stadium, better value for the planet you're getting with that design. So the functional unit is a very crucial aspect of life cycle design methodology. And as I mentioned earlier, this is not a rating system. Life cycle design is a methodology. It refers to international standards for calculating performance of buildings. And the main one is the EN 15978, which is a whole of building LCA standard. So what eTool does is we developed a software called eTool LCD, and that software calculates and produces results in a format that is compliant with the standard. So this standard was put together in 2011, a few years after the green building rating systems were formed. So I think there's an evolution there where we're integrating those standards into the rating systems and using LCA as a core part of the design process. And then you can see at the bottom very small letters, but it's a combination of a technical committee from different countries, 28 countries. So there's a very robust technical standard to support the way we calculate the performance of the buildings we're designing. And the main part of the standard is life cycle assessment. So the standard sets the scope that you need to include on your assessment, as well as the system boundary. So we see here different stages from product stage to construction to use and then end of life. So those are the system boundaries that are related to the building itself. And then you have module D, which is the green module here, which is the benefits beyond the building boundary, which is things like credits you get from using timber. If you burn that timber at the end of its life and you have heat recovery, for example, that creates credit for your models. Or if you're exporting clean electricity, that also creates credit for your model. So it's benefits beyond the building boundary. I'll quickly jump into the software to show you a basic look of the interface, and then we'll get back to the presentation. So before we jump to the next slide, I just want to show you what the interface looks like. This is the eTool LCD interface. It's all web-based, so all you need is jump into this URL, create an account, and start using the software. There are some commercial conditions for using the software for commercial gain, so please get in touch with us if that's the case. But here you have a bunch of research that we've done that's available to the public, and one of them are the benchmarks. So we have an Australian benchmark here, which is a code-compliant building in Climate Zone 5, where we quantify the emissions per occupant per year, as I said before. So this is the functional unit that we're using, kilograms of carbon per person per year, and their overall result is 4 tons. So very high emissions per capita for a residential benchmark in Australia. And then this is a completed model including a bunch of templates, what we call building components, we call templates. So you have different templates for different parts of the building, from appliances to the services and materials. They all come together in one model. Then you have some charts and visual information about how the model how the building performs and where the impacts are coming from. So you can see here that the dominating impact is energy, followed by products, then the recurring impacts, some impacts associated with transportation, then some end-of-life impact. So really about quantifying things to understand where the impacts are. If we want to draw down to the details, we look at the operational energy to see where the impacts are coming from, and that gives us some good idea of where the impacts are coming from. So all this comes from the templates, the services. So we have the end use, so let's say appliances. So you have here the TV. Then we have the annual demand in megajoules per year, and the associated carbon emissions, greenhouse gas emissions for this end use. So this gives you a really good idea to understand where the impacts are, and then from here we can generate a bunch of reports and improve the building. So you can assess the performance on multiple indicators just by completing your modeling. You then go, when you change to land use, for example, now you have a different indicator for your project, so dominated by energy again, so all the impacts associated with pollution, energy that will affect land. You can quantify impacts associated with ozone depletion. So you have a lot of impacts associated with the transport and the recurring impacts, so the methods that we are using to transport things and how much they affect the ozone layer. So just an example how you can use the software to quantify the impacts, multiple indicators, and then look at different reports that you can use to understand where the impacts are coming from. For example, you can run the top impacts report. It's all automated from the software. We have a set of different reports that you can then list the impacts by materials. You can list the impacts by transport. You can list the impacts by recurring impacts and so on. So software features that will help you understand where the impacts are. And then we have the recommendations tab, which is how you address those issues and quantify the recommendations that you're modeling. So it's very quick introduction to the software. I won't spend too much time on it because it's not the intent of the presentation, but I will get in touch with us if you're keen to have a dedicated demonstration about the software, and we'll organize that. So back to our presentation, we then look at the 5 ways that you can add value to your services using lifecycle design. The first one is using E2 LCD to meet state government requirements. We worked on the stadium, for example, that had a ESD target to reduce the greenhouse gas emissions. So Brookfield Multiplex had to run a model and demonstrate that their design is 20% better than the code compliant version. So it's large infrastructure projects and state government projects that are mandating those targets. There's a lot of opportunity there for use of LCA. Green Star is another big avenue for us. There's a lot of consultants using the software in-house, so they do the work themselves, and then they just peer review the modeling with E2 to meet the Green Star credit of the life cycle, the materials life cycle impact credit. So a lot of opportunities there with the Green Star rating for different tools, from design and as-built to Green Star interiors, communities. So it's good to see Green Star, using LCA. It's been over 4 years now that they introduced the credit as an innovation credit. Now it's as a part of the rating system. So we see a lot more of that happening in other rating systems as well. So Same with ISCA. So ISCA is the same as Green Star, but for infrastructure projects, where you can use the LCA to provide evidence for multiple credits. Also, I'll touch on that as well later down the presentation. The fourth item is the regulatory approvals, where developers need to demonstrate design excellence. Most of the cases are for density bonus, but we're seeing now more and more local government agencies putting planning policies with the minimum standard. So in order to get any new development off the ground, they have to demonstrate a certain level of environmental performance, and that is using the LCA to demonstrate that. So a lot of good stuff happening there on the local government space. Then we have the voluntary demand, which is designers, architects, developers, engineers that just want to do good for the planet. They want to use it as a marketing and sales exercise, and they're getting value out of it, just demonstrating genuine sustainability performance. So with the example of the stadium, for government requirement, they had to demonstrate a greenhouse gas reduction in different phases of the project. From design and construction, it was a 7% reduction. Operating phase was a 20% reduction in emissions associated with energy use, then as well as reducing the recurring impacts related to maintenance. So all of these items, they're all wrapped up together in one model, the whole of life carbon footprint assessment. Then you do a baseline, you compare that with your proposed model to demonstrate the savings. So quite nice photo here showing where the stadium is located, and yeah, they've done a fair bit to achieve that target, which is nice to see that coming from the government as a requirement. Green Star is different motivations, different tools. You get different credits. So legacy tools and Green Star communities, for example, can use as an innovation credit. The recent Design as Build tool, you get 7 points for your materials lifecycle impact credit, and same credit for Green Star interiors, but a lot more points. So a lot of value proposition here in Green Star. So here's some of the projects that we used, the software. Then we see, it's interesting, we see different ratings, 6 stars, 5 stars, and then the related GWP, the global warming potential. When you quantify things, you really understand the real impact on the planet. So this is a 6-star building that achieved a 34% GWP savings. This is a 5-star Green Star that achieved a 25% savings. And then we have same 5-star rating, but a lot better performance in terms of global warming potential with the 60% savings. So very interesting when you start quantifying things and using the LCA as a scientific approach to understand how the buildings are performing. Then we go into the infrastructure space. What I'll do, I'll just grab the link that has a lot of details about the infrastructure, LCA for infrastructure, and then I'll just paste here on the chat so everyone can have the link and jump online if you want to find out more. There's a video as well. So there's just a blog post with a video of a webinar we ran recently explaining how you can use LCA for infrastructure projects. So the general idea is that you can use a single model to provide evidence for multiple credits. So you get the same model producing the results in regards to the materials, what savings you're getting with your materials, what savings you're getting with your energy, water, waste, all in one model. So it's a very integrated approach. You see the proportion of the impacts each area has on the overall performance. But you can also use the model as an innovation credit, where you developing knowledge, you sharing knowledge, and then you're using that as a management credit as well. So multiple credits in one model and using that integrated design approach. Just back here with the ISCA, we've actually completed a project. The first project with ISCA so far, and that was the North Link project here in WA with John Holland. So just check our website for more details on that as well. Then we have the regulatory approvals, where local councils are taking a very progressive approach to quantify the performance of the buildings, and they're allowing life cycle design to be used as part of the planning policy to meet the environmental sustainability requirement. Here in Australia, in WA specifically, we've been working with local government agencies for the past 5 years, and there's a multiple number of councils that adopt life cycle design as part of their planning policies. So we see a lot more of that happening across Australia as a trend, as we see a lot of that happening worldwide as well. So it's just watch this space. I think that what we identify the benefits for local government to use the standard is that the standard is always being updated, and the technical body to keep it robust, to always stay relevant. So it's very easy when you refer to the standard instead of trying to set your own targets and policies. You just refer to the standard, and it's always constantly being updated. The other good thing about it is that it's a performance-based approach. So it doesn't matter where you are. There's always going to be specific to your building. If you say it needs to be 30% better than the code compliant version, you're always going to get an improvement, and you have the flexibility of using a performance-based approach instead of using a prescriptive approach, telling people what to do, what to include in their buildings. You just set a performance target, and they are free to come up with the best solutions, the most cost-effective solutions. So that gives designers and engineers a lot of flexibility to choose the most cost-effective strategies. And they're getting really good buildings at the end, so the councils are really keen on this. The last one is the altruistic purpose and sales and marketing campaign, where companies use the reports and the results as the CSR, campaign, or using for publicity, just branding strategy, branding campaigns, as well as marketing their products as being really progressive and basically intelligent design, and a lot of thought put into the design from early stages. So that has really good marketing, as well as the lower operational costs for the strata fees and the residents living on those apartments, or the tenants of commercial offices, for example. Investment and risk mitigation is quite interesting. We've had investment funds requesting the report in order to mitigate the risk for the future, what happens later on, where the market is all using green building ratings or green building strategies, and you want to mitigate the risk, so you want to make sure that your building is performing well. You run a report to actually quantify that and provide your investors a proof of quality. and also helps you with the sales, just getting quicker sales and a better value for your product in terms of resale value. So those are all really important aspects for the marketing sales campaign. The different designs, this one's quite interesting because it was 80% savings, which is very close to carbon neutral, which would be 100% savings. So on a development this scale, that you see that it is economically viable to achieve such a high performance, it's very exciting to see that it's possible, and then there's a market demand for it. Similar with the Handle property group one, where they are really progressive with the car park design, for example, reducing the car park space, therefore reducing the energy related to lighting and ventilating the car park, reduce construction costs, and getting a really good outcome. So just less reliance on personal transport and better performance building. So really interesting one. And then the altruistic purpose, people, designers, architects that just want to look for the best bang for the buck, but also they want to create a legacy. They want to make sure they're doing the right thing and they're achieving a genuine outcome. So they want to have a robust scientific proof that their design performs well. Okay, so then we get into the specific forms of engaging with E2. E2 can be engaged as consultants, where we use the software internally to run all the reports, provide recommendations, attend meetings, work through the design process with the other consultants. So a lot of consulting work. Or you can use the software internally. You can use the software in-house to run the reports and provide all the consulting work yourself. So that's the software part of things. And we have the subscription to use the software. So I'll jump on the website again quickly to show you the subscription page. It's on the software subscriptions, where you have different plans, different levels of subscription. Most popular one is the consultant subscription, where you pay $50 a month to use the software, but then you also have to pay a per project fee and have E2 to do a peer review, so independent validation of your modeling before you can use the results commercially. So jump online on this URL here, e2global.com software subscriptions, and you get all the information if you like to test the software. And that also comes with training. So part of the subscription model is that you get free training to use the software. So get in touch with us if you need more information on that. So we're now getting towards the end of the presentation. I'd just like to check if you have specific projects that you like to discuss, or if you have any other specific question about the presentation.